Okay, I'm going to go over a weight-based heparin protocol question just so you guys kind of understand how to do them. If you don't get it right this minute, remember there's only one question on the test that is like this, but you need to understand it by the time you graduate. Okay, so I've created a weight-based heparin protocol. It's right there, and that's what you need to use to answer the case studies. You will always be given, like every place that you will work at has a different protocol as far as heparin goes. So you just have to know what the protocol is at that facility, and they are all on the, whatever they have, the employee portal in my case, but wherever you work, you will be able to access it. Mr. Jones has arrived at the ER complaining of pain, burning, and redness in his left calf. When examined by the physician, he stated he had just returned from a trip to Australia. The flying time was 24 hours. Hello, red light. He stated he never had a problem like this before. The doctor diagnosed him with DVT of the left leg. His orders are bed rest with bathroom privileges and start heparin weight-based protocol. You're the nurse in the ER, and the order the IV of 500 mLs of D5W with 25,000 units of heparin from the pharmacy. So that is what you have on hand. You need to highlight that. My highlighting did not show up on this. You weigh the client, and he weighs 165 pounds, so you need to know that. And you're instructed by the physician to give the initial heparin bolus and the IV infusion before admitting the client to a medical unit. Now, the protocol is right here. So it's down at the bottom. When starting the heparin protocol, we're going to bolus at 80 units per kg. So that is what we're going to use for problem 1. And when initiating the drip, we're going to start at 18 units per kg per hour. And that's what we're going to use for problem 2. So the way I set my math up is I always like to do what I need first, because that's what's going to go on top. So I have, for this first problem, using the heparin protocol, how much heparin will you administer IV bolus? So it's going to be a bolus, so all I need is ml. And you're using a vial labeled 10,000 units of heparin per 1 ml. So we're going to do 1 ml over 10,000 units times 80 units over kgs times kgs over 2.2 pounds times 165 pounds. We're going to cross out all of the things that we can. So our pounds are crossing out, our kgs are crossing out, and our units are crossing out. So the only thing left is mLs. We get 13,200 divided by 22,000, which will equal 0.6 mLs. So that is our answer for this first question, 0.6 mLs. All right, how much heparin will be administered? All right, for the second question, how much heparin will be administered in the initial infusion? What is the rate of administration mLs per hour? Okay, so we're giving our our protocol states that we give 18 units per kg per hour. So we need to set it up in mLs per hour because that is what we need. So 500 mLs is what we have, and it's or 25,000 units are in that. So we put mLs over units. So 500 mLs divided by 25,000 units times 18 units divided by kilograms, because 18 units is what we need, times kilogram divided by 2.2 pounds times 165 pounds divided by hour. Then we cross everything out, so our pounds cross out, our kgs cross out, our units cross out, and we get 1,485,000 divided by 55,000, which will equal 27 mLs per hour. So that is going to be the administration rate. The third question is that it started at noon. You send them up to the unit. When will the nurse need to do? Later in the shift, she'll need to draw some blood at 6 p.m. Or he. I apologize for being not gender neutral. So at 6 p.m. the nurse will draw blood. 4. The PTT result is 38 at 7 p.m. What will you do now? So let's look at our protocol. So our result is 38. So Between 35 and 46, we're going to bolus 40 units per kg, and we're going to inform the doctor. And then our infusion is going to be increased by 2 units per kg per hour. Okay. So, first thing we need to figure out is our bolus. So we're going to do 40 units per kg. So we're going to take, we want units, right? So we need to take 40 units, divide it by kilograms, times kilogram divided by 2.2 pounds, times 165 pounds, which equals 6,600 divided by 2.2. So we need to give them 3,000 unit bolus based on their weight. So that's the first part of this problem. Then we're giving them 18 units per kg per hour. So we need to increase it by 2. So we need to do 18 plus 2, so it's 20 units per kg per hour. So then we have to figure out what rate that is. So again, mLs per hour is going to be our final. So we're going to put 500 mLs over 25,000 units times 20 units over kg times kg over 2.2 pounds times 165 pounds over HR. And that is going to equal 1,650,000 divided by 55,000, which will equal 30 mLs per hour. Then the fifth question I marked out because I needed more room. When can you expect the next PTT? So they're drawn every 6 hours. The last one was drawn at 6, so this one will be drawn at midnight. All right. And then the result is 98. So what should you do? So let's look at our protocol. So for our protocol between 86 to 100, we're going to hold our infusion for an hour, and we're going to tell the doctor. So we're going to hold it for an hour and tell the doctor, and then we're going to decrease it by 1.5 units. So we're going at 20 units per kg. So we need to take 20 and subtract 1.5, so we have 18.5 units, okay? And then again, we're going to do our mLs over our hours. So 500 mLs over 25,000 units times 18.5 units over kilograms times kilogram over 2.2 pounds times 165 pounds over hour, which gives us 1,526,250 divided by 55,000, which equals 27.75. Pumps go to the tenths, so 27.8 mLs per hour is our answer. If you have any questions about any of this, please let me know. Again, don't stress about it. It's one question on this one test, but you do need to understand it before you graduate. All right. Thank you. See you later.